Find the first four terms in ascending power of x. So remember the step, so we need to write our binomial coefficient, and we're only writing for the first four terms. And how we write our binomial coefficient is that we look at our power, which is 10. So its first term would be 10, 0. Second term would be 10, 1. Third term would be 10, 2. And the fourth term would be 10, 3. Since we want to write in ascending powers of x, so we must write our number term in descending powers. So it's 1 to the power of 10, 1 to the power of 9, 1 to the power of 8, and 1 to the power of 7. Then we write our x terms in ascending powers of x. So it's kx0, kx1, kx2, and kx3. Just a hint, how we type this into our calculator is that it's 10C0. Then type into our calculator, you should get this equals to 1, this equals to 10kx, this equals to 45k squared x squared, 120k cubed x cubed. So please have a go at typing this onto the calculator yourself. Therefore, the first four terms is going to be 1 plus 10kx plus 45k squared x squared plus 120k cubed x cubed. Then part B, we're given that this expression, the coefficient of x cubed. So remember, this is what we called the binomial coefficient, but this is the coefficient of x. This is the coefficient of x squared, and this is the coefficient of x cubed. So we tell that the coefficient of x cubed, which is 120k cubed. So this is the coefficient of x. It's 3 times the coefficient of x term. Our x term is this term here. It equals to 3 lot of this term. And we want to find the possible values of k. So this is just saying that 120k cubed is equals to 30k. And we can solve our equations here. So we have 120k cubed minus 30k is equals to 0. So factorize, we can take out 30k out, which we're left with 4k squared minus 1. We can factorize again. So we got our solutions, which is k equals to 0, k equals to minus a half, or k is equals to a half. Question 7. So we got this function gx, and we said we want to use the factor theorem to show that jx is divisible by x minus 5. So what the factor theorem is saying is that if this is a factor, so if x minus 5 is a factor, then g5 must equals to 0. So using the factor theorem to show that, all we have to write is to substitute 5 into the equation. And it equals 0. Therefore, x minus 5 is a factor. Then part B, we want to show that gx can be written as a product of 3 linear factors. Therefore, we're going to use our division, algebraic division. So I have 2x cubed plus x squared minus 41x minus 70, and it's divided by x minus 5. So using our algebraic division is that we take the first term and x. So we have 2x cubed divided by x, so we're left with 2x squared. So our first multiplier here is going to be 2x squared. Then we use this to multiply with x, we get 2x cubed. Then this multiplied with minus 5 is minus 10x squared. Then we're going to subtract. So 2x cubed minus 2x cubed is 0. X squared minus 10x squared becomes 11x squared. Then minus 41x minus 0 is just minus 41x, and minus 70 minus 0 is just minus 70. Then we look at this term here, which is 11x squared divided by x, which left with 11x. So we plus 11x. So 11x multiplied by x is 11x squared. 11x multiplied by minus 5 is minus 55x. Then we subtract again. 11x squared minus 11x squared is 0. Minus 41 minus 55x is 14x. Then minus 70. Then we use this divided by x. So we have 14x divided by x equals to 14. So we have plus 14. So plus 14 multiplied by x is 14x. 14 multiplied by minus 5 is minus 70. Then subtract it, we get a 0. So we know that x minus 5 multiplied by 2x squared plus 11x plus 14 is equals to 2x cubed plus x squared minus 41x minus 70. Then we want to factorize this into 3 brackets. So this factorized comes to 2x plus 7x plus